June 2019, paper 2, variant 3. Question 1 is cancelled because the micrometer screw gauge has been removed, so you can cancel question 1. Question 2, a brass ball and a feather are released at the same time. On Earth, the ball reaches the ground first. On the Moon, they reach the ground at the same time. What is the explanation for this? Both weigh the same on the Moon. No, they do not weigh the same on the Moon. Weigh less on the Moon. They do weigh less on the Moon, but this is not the explanation. They do weigh less, but this is not the explanation. There is a greater air resistance on the Moon. Actually, no, there is no air resistance on the Moon. And this is why they both hit the ground at the same time. When they are released, the ball and the feather do not experience any sort of air resistance, and they fall with the same acceleration, therefore hitting the ground at the same time. A heavy metal ball falls vertically downward through the air, passes through these points. The time taken is also measured. Where is the speed the greatest and where is the time the shortest? The greatest speed would be near the end, right? The greatest speed would be near or between L and M. What about the time? If you have the greatest speed, then you have the shortest time. Greatest speed and shortest time. So it is D. Question 4. On Earth, a spring stretches by 5 centimeters when a mass of 3 kilograms is suspended from one end. The gravitational field strength on the Moon is 1/6 of that on Earth. Which mass on the Moon would stretch a spring by the same extension? So the whole problem is that on the Moon, the gravitational field strength is much less. It's actually 6 times less. It's 6 times weaker than on Earth. And what is the thing that actually pulls the string? It is the force or the weight. It is not the mass. Again, it's not the mass that pulls the string. It is the weight. So what happens to the weight on the Moon? The weight on the Moon decreases 6 times. The weight on the Moon decreases 6 times. Which mass on the Moon would stretch the spring by the same extension? So if you want the same extension on the Moon, you'd actually need a mass 6 times larger than the mass on Earth. Meaning that if the mass on Earth is 3 kilograms, the mass on the Moon needs to be, you need to multiply by 6, on the Moon it needs to be 18 kilograms. Why should it be 18 kilograms? So that when the weight, okay, becomes 6 times less, when the weight becomes 6 times less, it is still equal, okay, it would give the same force, it would give the same extension on Earth. It would give the same force and therefore the same extension of that on Earth. Okay? X, Y, and Z are 3 regularly shaped solid objects. The dimensions are shown. Which objects have the same density? Density equals mass over volume. Can I find the density of each of these objects? Yes. So density equals mass over volume, 200 divided by 10 times 5 times 2. And then 200 divided by 6 times 4 times 3. And 50 divided by 25 times 1 times 1. 50 divided by 25 times 1 times 1. This is 2 grams per centimeter cubed. 200 over 10 times 10, which is 200 over 100, which is 2 grams per centimeter cubed. 200 divided by 6 times 4 times 3. What's 200 divided by 6 times 4 times 3? Okay, this would be around 2.7, which is wrong. So we only have X and Z. Only X and Z. Which calculation is used to calculate the spring's constant? We know that the spring's constant would be the force over the extension, force over extension. Okay. Now, a car is driven from rest along a horizontal road. The diagram shows the horizontal forces acting on the car. why does the car eventually reach a maximum speed? As it speeds up, what happens to the resistive forces? The resistive forces increase, right? The resistive forces increase as it speeds up, and therefore when the resistive forces increases, what happens to the acceleration? The acceleration decreases and thus reaches zero. So the resistive forces increase when the speed increases as well. Question 8. A beam of weight 6 newtons is suspended from two strings P and Q. Okay. The string P is 30 centimeters from the left hand end. As shown, string Q is not shown. The tension in string P is 2 newtons. What is the tension in string Q and where is it attached so that the beam is in equilibrium? We need the beam to be in equilibrium, right? Okay, so let's assume that we have a pivot. For example, we have a pivot, let's say at this point. Again, I'm just assuming that I have a pivot at this point. What are the moments around this pivot? The moments around this pivot would be 30 times 2 and 20 times 6, right? What's 30 times 2? 30 times 2, this is 60 newtons dot centimeter, right? And what's 20 times 6? 20 times 6, this is 120 newtons dot centimeter, right? So they're not balanced, right? It is not in equilibrium yet. It's not in equilibrium yet. What should we do? What should I do? I need to add the force Q or the string Q at some point to make them equal. So string Q, if I, for example, add string Q at this point, let's say that Q is at this point, which has a force which has an upward force. You need to make this upward force times the distance, this force times the distance equal to what? Equal to 60. Why should it be equal to 60? Because the clockwise moment, isn't this clockwise? Right? This is a clockwise moment. And this is an anti-clockwise moment. They're not equal, but you need to make the anti-clockwise moment equal to the clockwise moment. The clockwise moment is now equal to 120, right? And anti-clockwise moment is 60. You need to add another 60, which is due to Q. You need to add another 60, which is due to Q, somewhere on this string. Okay. Let's see. 4 times 10. Is 4 times 10 equal to 60? No, it's not equal to 60. 4 times 15, is it equal to 60? Yes, it is equal to 60, right? 4 times 15 is equal to 60. So if I say 4 times 15 from the left hand end, yes, the distance is 15, and you have a force of 4 newtons, it would be correct. Let's see. Are there any other correct answers? 6 times 10. Well, this 6 times 10, this is also equal to 60, right? This is also equal to 60. But there is a problem. There is another problem that would emerge if you say C. So a lot of you might say that B and C might be correct and D is wrong. Okay, let's say that D is wrong. Which would be correct? Is it B or is it C? I would tell you that B is correct. Why is C wrong? Why is C wrong? Because of the other. You have two conditions for equilibrium. Two conditions for equilibrium. Clockwise moment equals anti-clockwise moment. And the other one is that the upward forces should be equal to the downward forces. The only downward force we have is a 6 Newton force. The upward forces now is 2 newtons, and then you need to add what? You need to add 4 newtons. You need to add 4 newtons. And that's why B is the correct answer for this question. Okay? Now, moving on to question 9. Can I find the momentum and the type of the quantity? Yes, momentum is m, the mass times the velocity, and it is a vector quantity. Yes. What is the correct expression for the change in gravitational potential energy? It is mgh. GMH, or would it change? Would it differ? No, it wouldn't differ. It's mgh. A machine is very efficient. What does this mean? Very efficient. Produces large amounts of power. No, this is wrong. It uses very little energy. Again, it's the same. It doesn't have to do with how much energy it produces or how much energy it uses. It has to do with the amount of energy wasted. Amount of energy wasted. Friction. Okay, so I have a box is pulled along the floor, force of 3 newtons, friction acting as 1 newtons. How much kinetic energy does the box gain in moving 2 meters? How much kinetic energy? Okay, and kinetic energy is half mv squared. Do I have the mass? No, I do not have the mass. Do I have the velocity? No, again, I do not have the velocity. What should I do? Well, kinetic energy might be equal to the work done. Like, it would be equal to the work done in this case. So the work done is the force times distance, or the resultant force times distance. The resultant force would be 3 minus 1, which is 2, times the distance moved is 2, which is 4. Resultant force times the distance moved. It is the work done. Um, Question 13. What would increase the pressure on the stone? How can I increase the pressure on the stone? Decreasing the surface area, increasing the mass. Can you decrease the surface area? Can you increase the mass of the stone? Lowering the stone deeper into the liquid. Yeah, this would definitely increase the pressure on the stone. Water in a beaker evaporates when it is left on a bench for a period of time. Increasing the surface area and increasing the temperature of the water each change the rate of evaporation, which is correct. Increasing the surface area. Does it decrease the rate of evaporation? No, it increases. Increasing the temperature it also increases the rate of evaporation. This question is kind of cancelled because the thermal capacity has been removed from your syllabus, But if you want to think about it, if you want um, um, this heat or this storage heater to keep on producing heat for a long time, you need the thermal capacity to be large. Okay, you need the thermal capacity to be quite large, and you also need the temperature increase to be large. Why? So that it would store as much energy as possible. Latent heat has been cancelled, so this question is removed. Why does a metal rod conduct thermal energy much better than a similar sized plastic rod? Metal rods are better thermal conductors of energy because they have free moving electrons. The molecules are much closer. No. And the molecules in the plastic are much larger. No. Much more tightly held together. Again, this is the wrong answer. Molecular structure in the plastic contains no free electrons. Yes, it has to do with the free moving electrons. The metal surface of a kettle is hot. What happens to the cool air outside the kettle when it comes in contact with the hot kettle? What happens? The density, does it decrease or increase? Yes, it decreases. And the air, does the air fall? No, the hot air rises. The hot air rises. In which diagram will the diffraction be the least? How can I decrease the diffraction? How can I decrease the diffraction? By increasing the gap, increasing the gap and decreasing the wavelength. What is the wavelength of these sound waves? Can I find the wavelength? Yes. Wavelength equals speed over frequency. So the speed is 340 and the frequency is 1200. 1200, which gives you a wavelength of roughly 0.28 meters. Which conditions are necessary for light to be totally internally reflected? Total internal reflection. The incident light is in the less dense medium or the more dense medium? Definitely the more dense medium from the water or the glass. The angle of incidence, total internal reflection, has to be greater than the critical angle. What is the speed of the light in the liquid? First of all, you need to find the refractive index. N equals sine of the angle in the air over sine of the angle in the medium. Basically sine 40 over sine 25. What's sine 40 over sine 25? This is 1.5 or 1.52. Okay, 1.5 or 1.52. Can I find the speed? Yes, the speed, we know that n equals speed of light in air over speed of light in medium. To find the speed of the light in the medium, you have to say speed of light in air over n. So 3 times 10 to the power of 8 over 1.5. Let's say it's 1.5. What's 3 times 10 to the power of 8 divided by 1.5? This is 2 times 10 to the power of 8. An eclipse of the sun happens when the moon comes between the earth and the sun. Which statement is correct? Which statement is correct? Infrared radiation from the sun disappears before visible light. Ultraviolet disappears before the light. Visible light disappears before ultraviolet and infrared radiation. Infrared radiation, ultraviolet, and visible light all disappear at the same time. They do all disappear at the same time. Why? Because they have the same speed. Electromagnetic waves traveling at the same speed in the vacuum. Question 24. How far below the bottom of the boat is the shoal of fish? You have a sound traveling. The sound reaches the boat again. After 1.2 seconds, the speed of the sound is 1,500. What do I mean by that the sound reaches the boat again? That this is an echo, right? It's an echo. So basically the speed would be equal to 2 distance over the time. To find the distance, we would say velocity or speed times time divided by 2. The speed is 1,500 times the time, which is 1.2, divided by 2. Okay? This would give you a distance of 900 meters. Which statement about ultrasound is correct? Ultrasound, it has a higher frequency, yes, than audible sound. It is a longitudinal wave. Question 26. Metal bar is placed, okay, is placed inside a current carrying coil as shown in diagram 1. There is a small current in the coil. The bar holds a few nails as shown in diagram 2. When there is no current, the nails drop off. When there is no current, the nails drop off. So what type of metal is this? Is it steel or is it iron? It is definitely iron, because it's a temporary magnet. Effect of a larger current makes no difference. No, holds more nails. It's 26. Now, diagram 1 shows 2 thin uncharged strips of plastic. When they are rubbed with a dry cloth, they're shown in diagram 2. What is the charge on them and what is the force between them? The charge on them would be the same. Why? Because they are repelling each other, right? Positive and positive, or negative and negative. A cell has an electromotive force of 1.5 volts. What does this mean? A cell converts 1 joule when driving 1.5 coulombs, or the cell converts 1.5 joules when driving 1 coulomb of charge. C and D are wrong, right? C and D are wrong. The cell converts 1.5 joules of energy per second. Does not have to do with the time. Converts 1.5 watts of power. Again, it's not power. Yes, we know that the voltage would be equal to the energy per unit charge, right? Energy per unit charge. Again, energy per what? Per unit charge. Meaning that the energy would be 1.5 and the unit charge means one charge. 1.5 divided by 1. So 1.5 joules per one charge. Every charge has 1.5 joules of energy. Question 29. Okay, you have two wires, X and Y. Which row identifies as possible pair for X and Y if they have the same resistance? If they have the same resistance, which row would be the same for them? Okay, let's take a look. If the length of X is 50 and the diameter of X is 0.4, all X is always 50 and the diameter is always 0.4. The length of Y always increases, right? The length of Y always increases by a factor of what? From 50 to 200. What happened to the factor? What happened to the factor? You multiplied by 4, right? You multiplied by 4. So you actually need to divide the area. Again, listen to me very carefully. You need to divide the area by what? By 4. A lot of you might say, well, I'll just choose A because it's divided by 4, which is wrong. Why is it wrong? Because this is not the area, this is the diameter. This is the diameter. So what does the diameter have to do with the area? Actually, it is a square factor. It is a square factor. So when you increase the length, you need to decrease the diameter. Yes, you need to decrease the diameter. You need to decrease or okay. So which row identifies a possible pair for the for x and y? If the length increases, okay, if the length increases, then you need to, what should you do to the diameter? You need to actually increase the diameter. Why should you increase the diameter? Because when you increase the diameter, what will happen to the resistance? It will decrease again. So let's see. A and B are wrong. Why? Because if you decrease the diameter, the resistance would increase again. The resistance would increase again. You actually need to increase the diameter. Okay, should I increase the diameter by a factor of 4? As in D, for example, should I increase the diameter by a factor of 4? No, this would be wrong. Why? Because the diameter is always squared. The effect it has on the resistance is a square. It's a square factor. It's not a direct or an inverse relationship. Actually, it is a square relationship. Basically, if you multiply the diameter by 2, as in C, so the diameter is multiplied by 2. What happens to the resistance? The resistance is divided by 4. The resistance, why? Because it's a square factor. Okay? Again, I'll solve the question again. A and B are cancelled automatically. Why are A and B cancelled automatically? Because you'd say that the diameter, if the diameter decreases, then the length would increase, then the resistance would increase. You do not want the resistance to increase, you want the resistance to be the same. The length has increased, the length has already increased, right? The length has already increased. So what do you need to do to the diameter? You need to increase the diameter. Why? To decrease the resistance. So if I increase the diameter, as in C or D, which of them would be correct? C would be correct. Why? Because this is a square factor. Again, it is a square factor. So if you multiply, okay, if you multiply the diameter by 2, then the resistance will be divided by 4. If you think about the area of a wire, area of a wire is pi r squared. Pi r squared, or some people might say pi d squared over 4. Again, it's a square factor. Okay, it is a square factor. Okay. Hmm. Diagram shows a circuit including a lamp which the lamp is ringing, the bell is ringing, but the lamp is not lit. The bell is ringing, but the lamp is not lit. Which switches are closed? This is very easy. So it's say S1 and S3, right? Only S1 and S3. A lamp is used to connect the circuit so that the potential difference can be varied from 0 to 6 volts. Which circuit would be most suitable? Which circuit would be most suitable? Okay, let's cancel out some of these answers, some of the wrong answers. D would be wrong. Why? Because this is a fixed resistor. C would be wrong because this is a fuse. A lot of you might say, is it A or B? And most of you would just say it's A because you have a variable resistor, which would vary the resistance or would vary the current or would vary whatever, right? But A is actually wrong. Why is A wrong? Because this variable resistor is the only component, again, the variable resistor is the only component in parallel with the battery. So the variable resistor will always have a resistance of 6 volts no matter what happens. If you increase the resistance or if you decrease the resistance, it would have a resistance of 6 volts no matter what happens. What about this potential divider or this sliding contact? Isn't this a sliding contact? Yes, it is a sliding contact. So this whole resistor would have a resistance of 6 volts, yes. But the sliding contact, as it moves from point A to point B, as it moves from point A to point B, the resistance increases. Okay, as the length increases, the resistance increases. You can also say that the potential difference increases as well. It's all due to changing the length. So it is B. It is not A. It's kind of a tricky question. Kind of a tricky question. Okay. What is the current in the battery? Can I find the current in the battery? Yes, I need to find the total resistance. So the resistance of these two resistors, product over sum, or you can say because they are the same resistance, they have the same resistance. So the combined resistance would be 1 ohm. 1 and 2 is 3 ohms. So the total resistance of this circuit is 3 ohms. Can I find the current? I equals V over R. So 12 divided by 3 is 4 amps. 4 amps. Again, these two resistors are in parallel, so we can say product over sum, or just half of these resistors would be 1 ohm. Student is designing a lighting circuit for, okay, whatever. Anyway, you have 3 identical lamps. Each lamp is designed to operate at normal brightness when connected to a 12-volt battery. To operate at what? At 12 volts at normal brightness. Which statement is correct? Which statement? In circuit 1, each of the lamps is at normal brightness. Is this correct? Actually, no. Why is it wrong? Because they are all in series. They are all in series. So it is wrong. If one lamp fails, the other lamps remain lit. Again, wrong because they are in series. In circuit 2, if one lamp fails, the others remain lit. Yes. This is the correct answer because they are in parallel. Question 34 is cancelled. 35. Why is there a wire connecting the metal case to Earth? Why is it connected to Earth? Whenever you have an earth wire, this is very important. To improve the efficiency? No. Prevents the metal case from becoming too hot? Again, wrong. Reduces the risk of an electric, yes, it's an electric shock if the live wire touches the metal case. Prevents an electric shock. Alpha particles are directed at a metal foil. Most of the particles pass through the foil with little change in direction. A small proportion of the particles are scattered back at large angles. What does this evidence suggest about the structure of an atom? When you have some of the alpha particles that are scattered back, what does it mean? What does this mean? It consists of a charged center, much smaller than. It does consist of a charged center, but does this tell you why they are scattered back? No, it's not. It doesn't tell you why they are scattered back. It consists of a negative charge on the sides of the atom. No, this is wrong. It's not negative charge. Consists of a charged center, much smaller than the size of the atom, but with most of the mass of the atom. Most of the mass of the atom. In question in A, it had little of the mass of the atom. In C, it's saying most of the mass of the atom. Yes, it has most of the mass, which is the nucleus. We know that the nucleus has most of the mass of the atom. Question 37. In which direction does the force on the conductor act? So you have current. First of all, this is using Fleming's left-hand rule. Yes, Fleming's left-hand rule. North to south, it's pointing to the left, to the right. I'm sorry. The current is moving out of the page, and therefore the force has to be upwards, north to south, pointing to the right, and then the current out of the page, and the force would be upwards. A. What is nuclear fission? Merging, it is the splitting, yes, splitting of nucleus to create two smaller nuclei. Which statement about gamma radiation is correct? Gamma radiation consists of very small charged, no. Electromagnetic, yes, it is an electromagnetic radiation. Less penetrating, no. More high ionizing, no. A radium nucleus with a nucleon number of 226 decays by emitting an alpha particle. Alpha particle, nucleon number 226. The proton number of radium is 88. What are the nucleon number and the proton? Nucleon number would decrease by 4, so it's 222. The proton number would decrease by 2, so it's 86. Okay.